Right, so we are looking at logic gates here, right? What I want to remind you before we answer these questions is there are 4 gates that you are going to need to be aware of in the AQA spec, all right? If it was the OCR spec, they've only got 3, but you've got 4, all right? The first one is here, which is XOR, and I'm going to go through that. What exclusive OR looks like, just so you're aware, is when you draw the gate, it has the line on the back of it as well. Okay, that is what exclusive OR means. Now, the outcome of an exclusive OR is only one switch is allowed to be turned on. That's the best way for you to memorize it. Okay, it's basically one switch is going to be is true. All right. So if you have a look here, that is both of them are false. So therefore, it is false. One of them is true. So therefore, is one of them is true, and this one it is false because you need to have one or the other. Now, if, for example, it was, so that's XOR, and just so you'll remember the symbol, it's a plus with a circle behind it, yeah? And then an OR, standard OR, looks like this. I always compare it to like a Star Trek or a spaceship or something to help me memorize the OR, all right? And that is just a plus symbol, all right? Now with an OR gate, so let me just write down the output of an OR gate, all right? So if it was just OR on its own, if you wanted to make a note for your revision, all right, that would be 0, 1, 1, 1. Okay, because it just means that with an OR gate, only one needs to be true. All right. Then you've got an AND gate. All right. With an AND gate, I always remind myself the last letter is a D. It looks like a D. All right. With an AND gate, both must be true. So all the switches. So if this was an AND gate, it would be 0, 0, 0, 1. Because both of those are true. Okay? The last one we have is, I'm just going to show you a NOT gate. A NOT gate is a triangle with a circle at the end. And what it does is it inverts. So whatever comes in, the opposite comes out. All right? So if I did here NOT A, okay, that would be 1, 1, 0, 0. If I did not B, that would be 1, 0, 1, 0. Okay, so with a NOT gate, the output is the opposite. So that's just some reminders of rules before we go into these. So let's have a look here at the first question. I might split this into a couple of videos so that it's not too much at once, all right? But it says here, the system has 2 sensors, A1 and A2. Perfect, all right? They detect if a customer is near. The audio plays if either of these sensors are activated. The word either basically means and. Sorry, not and. Means or, all right? The word either means or. So, first of all there, it is an OR gate. Okay? If it said only one of the sensors can be triggered at a time, what would I change it to? XOR. All right? So you've got to look for the wording and what it means. You've got to just read it and just take out what you can from it. The system should only play if another audio system is not playing. That's S. All right? So therefore, that's basically saying that this system here will only play if another audio system is not playing. So the point is that there's an advert on the screen, and when somebody comes close to it, it's going to start playing the advert, right? But it's not going to start playing that advert, so the sensor's been triggered. So if that is true, all right, it's not going to actually turn on the advert unless it wasn't originally playing. So what you do with that is you have a not gate there. It even tells you there is not. So you know that S is a not gate. Yeah? So that is a not, and a 1 comes out here. All right? What gate are we following up with? It's an AND gate, because basically it won't play unless the sensor's been triggered and it wasn't originally playing. Okay, so therefore we've got, I'm going to move this up here, a D there. Alright, making sense? So it's just about decomposition, you know, a programming skill that you have. Right, let's go again. Let's turn over now. State what is labeled at G. Remember what I said? It looks like a D, so it's a... Good. State what is G2. Or. State what a NOT gate does. This is where your definitions need to be on point. Alright? So, a NOT gate will, sorry, move that up. A NOT gate will flip or invert the switch input. Alright? They will award a mark if you say the zeros become ones. So some of you may have done that. They will award a mark if you said the opposite of what goes in will come out. Alright? It's just about you demonstrating you fully understand how these switches work. Now, it says complete the truth table for the logic circuit shown in this diagram here. Alright? So what is the output of D? What's the output of D? No. I want to know what the... Let's look at how to do this. D is so A and B are going in. So what is D? It's an AND gate, isn't it? So if you write above it, it's going to help you when you're working out your answers. Now let's look at E. All right, E was D or C. So E is D or, I think that's right. So E is D or C. So if you write above it, it's going to help you work it out. And F is E or D. So E or D. All right. So let's work this out now. All right. So D was AND A and B. All right. So let's work that out. A and B. What's the output going to be there? A and B. It's going to be 0 because both the switches aren't on. Here, A and B. It's going to be 1. Right. Now we move over and we said if you looked at the gate, right, so for E, it's actually E is D or C. Now you finish that column, you can work this out. D or C. D or C. Remember, or the rule for or is that only one switch needs to be true. So we've got D or C. They're both 0, so what's the output? 0. D or C, one of them's true. So what we're going for? 1. And again, C or D, 1. Now F is E or D. So again, you can check these answers are right. Look, 0 and a 1 is a 1. 0, 0, 0, 0, 1 is a 1. 0, 0 is a 0. 0 or 1 is a 1. 1 or 1 is 1. 1 or 1 is 1. Okay? So it's a process. If you write labels above any tables that you get like this, it's going to help you visualize it. All right? In fact, they do that in some of the other questions that you may have, okay? So that is worth 1 mark. That is worth 1 mark. And that is worth 1 mark. Okay? Now, there's a logic circuit here for a truth table. Let's have a look here. 0 and 0, the output is 0. 0 and 1, the output is 1. 1 and 0, output is 1. Looking at logistically there, what sort of gate would that be? And it's not XOR because if you look here, both are on and the output's true. So you should have just had an OR gate there. Ta-da! Alright. The next one. Alright. I'm going to pause the recording at this point. Alright. Because I'm going to have to flip the pages over. I might actually be able to do this. It says there's a burglar alarm. When it is armed, turned on, the window or door is opened. Alright. So when it is armed, so when the alarm, so a burglar alarm sounds an alarm when it is armed. Alright, so if the alarm, when you leave home, you turn the alarm system on. If a window or a door is opened while that is on, the alarm's going to go off. And it shows you a truth table here. Alright? It wants you to use the logic gates to draw that. So let me put this at the side. So you're going to draw a logic circuit here, all right? So first of all, right, look at the at your rules here. I wonder if I can fit this in. First of all, the alarm's got to be turned on, and and the window or door's got to be open. All right. So C is a window, B is a door. All right. That's either or, isn't it? It's one or the other. So let's look at that. The window or door is open. So let's look where the window is. Window, door, C, B. That's window or door. Let's make sure we get our OR gate in there first. So that's one of them. Alright. But if you remember, the alarm must be turned on. Alright. So if that is a 1, but that's a 1 or a 0, so if the windows or doors are opened, that's going to be true. So we're saying now if the window, which is C, or the door is open, we get true there, right? But the alarm will only trigger if the alarm system is turned on. So what we're going to need to do, we've got two conditions that need to be met here, this condition and this. So that's how we know we finished that with gate B and gate A. Alright? It's about reading and taking this. You can look at this, but actually it was this sentence here that helped me get to the answer. So look, alarm is turned on and, so there's an and between that condition and that, but then there's another condition within it, which is your or. Alright? So let's go to question 6. So, a partially complete logic circuit detects if a computer system has been set up correctly. There are two keyboard inputs, keyboard A and keyboard B. Either can be connected to the computer system. However, if they are both connected, then the computer system will not work. What's that saying there? Only one can be connected, all right? Output B has the value 1 if keyboard A or keyboard B, but not both, is connected to the computer system, and 0 otherwise. All right? So, let me put in what the labels should be, and then we'll show you how it works. So what you should have had for label 1, even though it's over here, all right, is a not. All right, label 2 and label 3 should have been an and label 4 should have been an or. So let's look at this logistically. All right, there are 2 keyboards, A and B. All right, so there are 2 keyboards, A and B, and either one can be connected to the computer system. All right. However, if they are both connected, the computer will not work. So first of all, it says there's an or there, so that's why the or was there. Output P has the value of 1 if keyboard A or keyboard B, all right, but not both, is connected, and 0 otherwise. So what you've got here, if I put in a 1 there and a 1 there, that would be then a 0, okay? But then what's happening here is that 1 would go down here. But by putting a 1 in here, that becomes a 0. Now, obviously, what other gate could you have used on its own rather than doing these? You could, if there was an XOR there, you could have like joined them together, but they've used 2 separate gates, which is why we had to use the AND. And if you look, the NOT negates it, and obviously with an AND, it's sorry, obviously with an AND both need to be true. That's where this condition, look, output B has the value of 1 if either keyboard A or B, but not both. All right. So if I didn't put that not there, that wouldn't have worked. All right. I'm going to stop that recording there.